Okay, I just was browsing the Devoxx app, and I don't know what you are doing here. I don't know what I'm doing here. All the rest of the sessions are so awesome. Thank you very much for coming. I'll do my best to prove that you did the right choice. And it will be hard. We're going to talk about DevOps at scale, and I'll try to present it as a Greek tragedy in 3 acts. And kind of the presentation way was obvious to me, because anyone knows what distinguishes Greek tragedy? Everybody dies. Thank you very much. So DevOps at scale is obviously a Greek tragedy. That's kind of comes without saying. We'll go by the rules, and we'll start with the little introduction. This is me, Baruch Sadogursky. I'm developer advocate with JFrog at JBaruch on the internet. If you are already here, feel free to follow me on the internet. We'll start with an overview of what the hell is DevOps, right? We are on, I don't know how many years, 4 years into this movement, and it looks like we have a pretty solid way to talk about DevOps, but maybe not. So before that, show notes. I prepared a special page for you with the video tomorrow. The slides are already there. All the links about this talk, ratings, comments, and raffle to thank you again for coming here. You see the link right here on the bottom. Let's see if that works. Here we go. jfrog.com/show notes, so you can find all the information there. And going back to what is DevOps, Venn diagrams. This is how we explain everything starting in very ancient times. And this is kind of the canonic explanation on how DevOps work. We have dev, we have ops, we merge them together. This is DevOps. Apparently QA came a little bit late, right? They didn't think about it from the start, so it didn't make it to the name. And changing the name, I don't know, dev QA ops, QA DevOps. It doesn't play well. And by the way, note how S stands for security in DevOps as well. So this is it. On the other side, we can take a little bit different approach, and this is what we are going to talk to today, is the merge of the change in technology, process, and people. And this is the sweet spot between those is, of course, DevOps as well. And this is what will be kind of our view on DevOps today. So we will take a completely fictional company called Pentagon Inc. They are in the money processing business, as some other company with geometrical shape name. That's a joke that works better in the United States, I can assume. Yeah. We'll tell their story in 3 acts. Act number 1, called the Fire Brigade, also known as reactive ops. We are going to talk about why they fighting fires and how they are doing. Before we start, we will set up the stage and we will see what's going on in this company. And well, as I mentioned, beginning 3 developers. 3 developers, they came together and created this awesome startup. They come from an on-prem background. None of them did any cloud work or being in any contact with the cloud yet. They are smart guys, so they know what they are doing. A little bit on the hipsterish side, so they pick kind of a little bit hipsterish stack. JavaScript, Node.js, reactive microservices, everything that the cool guys are talking about. Let's talk about process. For 3 people, there is no much process at all. Something very basic for structuring development, maybe Kanban, a whiteboard with stickers, or not more than that. QA, as I mentioned, they are good developers, so they know what they are doing, all the right practices, test-driven development, unit integration, automatic tests, good code coverage, everything is fine. Well, ops. As I mentioned, they are developers. They have no idea what ops is. They went to a couple of conferences like this one and others and learned couple of terms that they really liked. And one of the terms they really liked is serverless, which means there are no servers. So it means that we don't need to take care of them. And this is wonderful. This is what they want. And the other they liked even more, no ops. That's great. No ops means, well, we don't need to take care of ops. This is just perfect. And this is what they kind of embraced. Tools, again, very, very basic. Something to manage their backlog and their issues. Maybe Jira, maybe issues on GitHub, or anything else that basic. GitHub for their source control, Bitbucket, GitLab, Travis CI or any other CI server in the cloud, Drone.io, Shippable, CodeShip. There are a whole bunch of them. And again, they're going to the cloud. They don't want to do any ops. They don't want to maintain any servers. So everything is as a service. And then the platform, again, something serverless. And there are a lot of them. It could be Lambdas, functions, AWS, platform as a service, Beanstalk, Google App Engine, Oracle Cloud, whatever. Any kind of cloud that they don't need to worry about servers or ops. So this is kind of the landscape, and let's see what happens. So as every startup in their early stages, they basically do two things. They write code and they wait. What do they wait for? They wait for their first customer. And then, let's say, a major conference, which now is a franchise of conferences, trusts them to process their payments to buy tickets, right? And I'll invent some name, maybe Devoxx sounds like a good conference. They go with those guys and they trust them to process all their payments for tickets and everything else. And that, of course, brings the next scene, which is a hardcore celebration, drinking, they party like there is no tomorrow, first customer, first big customer, and everything is great. Friday night, 3 a.m., they kind of drink, and then customer calls, nothing works. What is their first reaction? What do they do? Yeah, well, they panic, first of all, right? This is kind of the first thing. They panic, but after a while, they get themselves together and they charge. Now, the good news are they are all the company, the support, all the developers, everybody, 3 guys, and they have all access to root, so they can log in and start looking what's going on. And they're like, okay, let's where do we start? Let's see the logs. Where are the logs? Well, they are somewhere in the cloud. Where are they in the cloud? We don't have any servers. We don't have any ops. We have no idea where they are. They start charging. They discover the logs. And then they go like, oh, yeah, here are the logs. I see this exception, and it's in 2 a.m. And the other goes, yeah, I see kind of related exception, and it's 4 a.m. How that's even possible? Well, time zones. Some of their servers are in different time zones, so they do time zone acrobatics. Anyone remembers doing time zone acrobatics? Yeah, well, of course, right? So that's a lot of fun. And eventually they find a problem. One of them, a guy, we will call him Billy, had a great idea after a couple of beers, or maybe a dozen, and he actually went and coded this great idea. And now you remember their tools, right? Once the code is committed, build, deploy to production, runs in production, or in our example, not very much. He had to comment a couple of tests in the middle because they didn't pass, and that's what happened. So the fix is easy, right? All we need to do is revert to a previous commit, and then it will run, it will build, it will go to production, and it will fix the problem. Well, the problem is it doesn't build anymore. Which is kind of weird because just a couple hours ago, before they started to party, they actually pushed their last commit and everything was great, but now they have some kind of weird errors about some dependencies which are not found. How can that happen? Someone remembers that? Right. Left pad. Okay, let's do that. Who didn't hear about left pad? Who doesn't know about left pad? Oh, just, okay. enough people deserve a brief explanation. A year and a half ago, all the internet broke. The reason why the internet broke is that a lot of the builds stopped working because they were dependent directly or transitively in a library package called leftpad. Now, leftpad are 11 lines of JavaScript code that actually do what the name implies. They pad strings from the left. And apparently you need a library for that in JavaScript. The author of this famous library went to some fight with the organizers of MVN registry, which is the main repository of JavaScript code, and eventually took his library with him and left. And another wonderful thing about JavaScript is that when npm builds, not only it checks for new dependencies, it also checks, what about my old dependencies? I already have them in cache, but let's check once more, and if they not exist anymore, let's fail. Which is kind of weird, but this is how it works in the JavaScript world. Long story short, they probably didn't write those 11 lines of code because this is not what you do in JavaScript, but they found it somewhere in the cache, and then they restored this dependency and managed to build. Now, the problem is that this kind of behavior keeps coming back every once in a while. Sometimes those are new bugs, sometimes those are old bugs, sometimes the customer calls that nothing works, sometimes they discover it themselves, but this is a firefighting mode in which a lot of the startups spend a significant time in the beginning of their journey. And anyone was a part of the startup that was in this firefighting mode? Yeah, a couple of hands, obviously. And that makes sense. And this mode is okay, I guess, until it's not. In some point of time, we need to go to the next level, which is Act 2 of our tragedy, and it's called the smoke alarm installers, or reactive improvement. And in this act, we'll try to install smoke alarm detectors in the places where fires already happened, so they won't happen again. Let's see what's new, what changed with the company. Well, first of all, they raised some money. And now they are a group of 30 people, 26 new developers, one developer with ops background. He actually knows that servers do exist, even in serverless. They are you just don't have them, but they are somewhere. And there is no such thing as no ops because someone does the ops, sometimes it's just not you. 100 customers, they are growing. Eventually, they have a successful product. Support team, so they got kind of tired of being waken up and interrupted during the day and waking up during the night and weekends, so they hired a bunch of guys that do the kind of the first line of defense, those guys that, did you try to switch in off and on again, right? That's kind of support. The process evolved as well. 30 people is like what, 2-3 Scrum teams. Scrum sounds like a good process. Exploratory testing, who knows what exploratory testing means? Yes.
So when you do not check some feature, but you just go through the existing system?
When you go through existing system manually, what it sounds like?
Same as smoke testing?
It's just a fancy name for manual QA, if you ask me. Right? Yeah, just people hate the manual QA, so now we have another term to do the same. No, I'm just kidding. It's actually a little bit different, but for the sake of our story, it doesn't really matter. It's something that gives another layer of protection on top of automatic tests and test coverage. Someone that actually clicks through the system and verifies that everything that everything works. Well, yeah. Now they discover that they do have ops because they have a guy that actually knows it and actually told them, okay guys, there are servers and you run your code on those servers and we need to take care of them. Developer on call, another kind of measure for interrupting less. So now the support won't wake up the whole team in the middle of the night, but there will be a dedicated developer on call which will be interrupted if the support cannot fix the issue themselves. And of course, fix this stupid thing with the logs. Tools evolves as well, so now they need some kind of a knowledge base, Confluence, Wiki, Google shared Google Doc, whatever it takes, some kind of repository to proxy the artifacts, the dependencies, and host their own artifacts. So rollback will just be take the last build and deploy to production. Normal logging, there are tons of different tools for that. Stuff like Sumo Logic, the one that I picked, but also Splunk, log entries, Logly, Elastic, Kinbana and Stash, and whatever. There are tons of them, and some of them better, some of them worse, but something to process the logs. It's also kind of a poor man's APM, application monitoring. We can set up alerts in those systems and then get alerted if something went wrong. And then, who is old enough to know what pingdom is? Here you go. Those are my ops guys here. Well, pingdom is a great service. It does one thing. It pings a URL and tells you if it's up or down. Right? Not very sophisticated, but at least it solves the problem of customer calling and telling us nothing works. Because this is kind of embarrassing. Hey guys, do you know that your system is down? Let me check that. It's not a good answer, right? So this is solved. They have pingdom, and let's see what's happening. So just to remind you, they raise some money. What do? First thing? They celebrate, they drink, of course. They drink, and you know by now, Friday, 5 a.m., everybody drunk, customer calls. Well, it's not nothing works because they have protection against it now. It's something doesn't work. Let's say Visa and MasterCard transactions are fine, American Express is failing. So you remember they have the support team. What the support guys do? They panic, right? You know by now. It's repetitive. It's easy to learn. You're developers. You have this mind, right? So yeah, of course they panic and then they charge. So they know what to do. They go to the knowledge base. They check there, is there anything about American Express transaction failing? There is nothing interesting there. Then they wake up a developer on call. Now the developer on call is obviously, he and the support guys are obviously the only sober people in the company, and they're like, well, I didn't touch this code. You know who wrote this code of American Express? You guessed it, Billy. And Billy is wasted. Billy is not on this planet anymore. So they try to somehow wake him up, and I guess they have to drive to his home and shake him and pour some water on him, and he's like, what? Yeah, I remember that. I think I already saw this error, and I think I fixed it, and the Jira looks kind of weird. It's closed, but it's not done. It's resolved, but it's not finished. Something is not right. And they're like, you know what? I think I know the problem. Let me do something. And then he logs into his computer, and then he's like, okay, it's done, it's fixed. And they check, and everything's fine. So everybody go back to sleep, and now something new happens. And this is a new process that actually install those smoke alarm detectors that I spoke about, and this is a process of root cause analysis. Now I have here an example of a real-world root cause analysis from a project that a friend of mine and co-author of this talk, Leonid Igolnik, managed, and we can try to analyze the root cause analysis report by looking at it. So we have some metadata here about where it happened, when it happened, how long it took, and then the first part, the long part, is a timeline of events. And a timeline of events describes what happened, who did what, and we had to kind of censor out the names of not so innocent And it goes step by step. And in our example, it would probably be something like the customer tried to execute American Express transaction and it failed, and the beginning of investigation, what we did step by step. And the interesting part here is how this information is gathered. So I would say there are two options. Option number one, there is this legal secretary with this tiny typewriter that sits in the middle of the corner and types everything that happens, and it's usually not the case. The other option is using some kind of a log from your corporate chat, in which you probably have a dedicated room for this incident in particular or for incidents in general. So it's very important to actually type in what you are doing and not being like, Billy, yeah, I'll fix it. I fixed it right now. Because I fixed it right now won't give any valuable information for the root cause analysis report. The second part is the symptoms. And this is important because this goes directly to the knowledge base. Right? And the symptoms, if the American Express transactions fail with those errors in the exact same way, that means that probably it is this problem, and we can go back and look what happened and fix it in exactly the same way. Technical explanation of what happened. In our case, it will probably be that we set up the queue of American Express transaction incorrectly, and we didn't measure the size of the expected size of the volume of the transactions correctly, and the customer had a promotion. Whoever pays with American Express gets 50% off, and of course the number of American Express transactions peaked, and the queue was overflown. That's kind of technical explanation what happened. Root cause analysis, one line or one sentence or one paragraph of what actually happened. In our case, it will be, well, the American Express transactions queue overflown. And then next steps. Now, this is most important because this is the smoke alarm detector. Right? This is where we guarantee that this problem won't happen anymore. Others will, but this one won't return because we guarantee here that we fixed the code, added monitoring, added some kind of a log alert, did something to make sure that it's not happening again. It's usually possible, sometimes it's not, but usually it is possible to guarantee. And in our example, it will be, okay, we need to increase the queue. By how much? So they ask Billy, and Billy goes like 42. Why 42? 42 is good, trust me. 42 won't overflow, 42 is perfect. Okay. So they set the queue to 42 because they actually don't have any better way to assess it. We're going to talk about it later. Now, this process of root cause analysis not only a technical investigation, but also sort of kind of a retrospective on what happened. And this retrospective not only important inside the organization, but also very, very important for your customers. And what the industry teaches us is that the customers are extremely forgiving for errors that happen once. If we come to the customers with such an analysis and say, look, this is what happened, and this is how we guarantee it won't happen again, a lot of sins can be forgiven, sometimes things that you will never think that will ever be forgotten. Let me give you an example. What do you think the worst that can happen to a cloud company? Yes. Data loss. And the canonical example that we have since last 6 months is the GitLab database incident. This is an amazing story of a service provider, cloud company, loses 6 hours of customer database, of customer data. And it starts very innocent. Someone deleted a production database. Now, that's okay, that happens. All of us deleted a production database at some point of time. I hear this guilty laugh. And the problem is not that. The problem is what we do next. What do we do next? Well, we recover from backup, right? This is easy. So let's see how that went. And that was daylight in the United States, so we kind of watched it in live, and that was fascinating. So the guy who deleted the database is called Team Member 1. That's his nickname for the RCA. This is how they kind of censored the names of not-so-innocents. And he's going to restore a backup, and he doesn't know where the backup is. So he asked team member 2, and then eventually they find it, but it's empty. It's big enough, right? And then they check for SQL dumps, and it turns out that SQL dumps were performed with a wrong version of the dump tool, which actually means that no SQL dumps were made at all. No despair. How about disk snapshots? Disk snapshots exist, but not for the databases. And how about replication? The replication procedure is super fragile, prone to error, relies on a handful of random shell scripts, and is badly documented, which is a very fascinating way to say we don't have any replication. How about backup to S3? Well, the bucket is empty. Out of 5 techniques of replication and backup deployed, none are working reliably or set up in the first place. We are ending up restoring a 6-hour-old backup. Now, we are watching that and we go like, it was funny, it was sad, it was emotional, it was everything, but I personally saw that that's all. That's the end of GitLab. And no. As I mentioned, customers and users are extremely forgiving if you are honest with them and explain them how you are going to fix the problem. Je suis team member 1, I think that's my favorite. This is just hilarious. They send them money and cookies and what's not, tons of love. And interesting story about team member 1, he was up to a promotion just before the incident, and he was actually promoted, which is the right thing to do because this guy have battle experience. You want this engineer. He's a very funny guy. This is his description on Twitter, database removal specialist. So smoke alarm detectors we know now how to install, and life is getting better, right? We have more and more repeating incidents. We don't fight fires anymore. But then the perfect storms arrives. Act 3 is where everybody dies. And it comes with a certain size. In our case, more money, more developers, 100 people on a development team, which is a big development team by any scale. 5 guys with the ops background, a whole performance engineer. Alexei Shipilov just picked up the door and left because he knew I'm going to speak about him. Chief architect. Like stuff that the big guys actually do. Customer success team, now you remember this poor developer call that had to actually try and wake up Billy because he didn't know about American Express? So this is solved by subject matter experts from every subject of the system participating on call together as a team. During the day, they help prevent the rest of the team to be interrupted. During the night, they help to prevent the rest of the team to being woke up. And there are different techniques of assembling those customer success teams. Sometimes you volunteer people into it, and that's very, very important because pain is instructional. If people need to fix the problems they created, they will probably create less problems. Sometimes there are guys who just love this kind of job. They kind of play a detective in a murder case in which they're also the murderer, and people like it. Some people like it. So anyway, you need to get the pain of the support to the developers, and the customer success team, rotating customer success team, is a very good way to do them. They are big enough, so they have legal, someone needs to count, they have 2 rounds, a lot of investors, someone needs to count investors' money, so they have CFO now, 1,000 customers, big successful company, and of course process evolves as well. 8 Scrum teams working on the same product. It's hard. There are some efforts to build a structure about that, and one of them is safe, scalable, agile framework. Probably when you are in this scale, it's a right way to go. For me, we are a relatively small company. We are not in this level yet. So for me, when I go to the safe side, my eyes start bleeding of the amount of process that they have there. But I think probably in some point of time, this is what it takes. System testing. Now remember, the system now is huge and it needs to work on some performant manner. So there are steps that need to be taken that cannot be taken by the regular developers, right? You need to set up labs in the cloud or on-prem. You need to write software that will be tested by your software. So there is an expertise that special people need to participate in implementing. Okay, now this is where you leave the room in anger and say, what the hell, this guy is talking about DevOps, and then he has actually ops team on the slide. And, well, there are 2 ways of doing DevOps today, at least. Maybe it will change. But today we see 2 ways of doing DevOps. One of them is what we call the Netflix way. The Netflix way is the pure DevOps, the beautiful, divine way of doing DevOps. Everybody have access to prod. Everybody do both development and operations. Everybody are aware and care about the tools that are used through continuous delivery and deployment pipeline. And there is one problem with that. It only happens in Netflix. It only happens in Netflix for 3 main reasons. First, they hire only people who are the best and actually can do it. Second, they pay way above the market to be able to afford those people. And third, those guys are streaming movies. I mean, if Netflix is down, is upsetting, but it's not a bank or anything critical. Right? I don't know, Victor. Netflix and chill. And you won't be able to chill. Yeah, it is critical for some people. But you know what I mean? The rest of us, we don't have none of those 3 luxuries. We don't have access to those people. We don't have such money. And sometimes we do critical systems like payment processing. So the other way of doing DevOps, and this is what we see today, is having this special team, which does 2 main things. First, those guys lay the foundation for DevOps automation. Those are the guys who set up Docker. It's a DevOps talk. I cannot not mention Docker. Docker. Now I'm good. Okay, so they set up this. I don't need to say it anymore. Chef, Puppet, Ansible, all this zoo of tools, Spinnaker, and what's not. They take care of all that. They know this stuff. They love this stuff. Probably other developers not so much. They would love to hear how it works, but do they want to implement Docker? I did it again. No, they don't, but for a good reason, obviously. This is what they do. The other one is advocating for DevOps. Those are the people who go to developers and say, guys, this is how we do things. This is your pipeline. This is how you push the button when you commit the code. It ends up in production. It's your responsibility that it ends up in production, not ours. We are here to help you, give you the tools, teach you, but it's yours. So this is the ops team that we see in the majority of the best firms that do DevOps. They have something like that. Escalation path. you remember, we had this escalation from support to the developer and call to the customer success team, but also managers who takes care of orchestration of what resources needed, and sometimes all the way to the CEO. And why would you want CEO on the escalation path? Two reasons. First, sometimes it is the end of the escalation path. The problems are so big that CEO have to step in, play golf with some people, and this will be his contribution for solving the bug. The other reason is, escalation path is a piece of paper or a document in which you have names, times when to call them, starting the beginning of the incident, and mobile phone numbers. Now, let's say CEO is on this list, and whoever is taking care of this problem have to call CEO in 6 hours after the incident began, and this is a mobile number, and now it's 4 a.m. Now, miracle things happen. All the bugs are suddenly solved in just under 6 hours. SOC 2 or any other regulation, government regulation, is also very important in this problem, and SOC 2 is here not just to say, oh, it's a pain in the ass, but to see how modern DevOps deals with those kind of things. So I don't know if you are aware, probably SOC 2 is kind of a North American thing. There are controls in SOC 2 that looks like a complete violation of DevOps. One of the controls, for example, is ensuring that people who write the code and people who deploy the code to production are different people. And then you go like, okay, I cannot do DevOps, goodbye. It's written that we cannot do that together. It's just here. And the interesting part is that there are ways around it. And for this particular example, the ops team that I mentioned earlier, they are the ones who are in charge in deploying to production. They build the pipeline, they control the pipeline, they ensure the quality, the security, the permission, and everything. And then everybody can deploy to production on this pipeline that the ops team is managing, and then it's fine. So here is another reason why this team is important and can exist even if all the team does DevOps as close as possible to this ideal world of everybody do everything. Non-functional backlog, another important aspect on this kind of scale. Performance, monitoring, and other aspects are now a part of this process. Tools evolve as well, so for example, something like configuration management and proper APM is about time to introduce. And another change that happened in this last act is that Billy got promoted and he is now the head of engineering, and by the quality of the greeting card you can see that he is not really beloved in his company. Now you know why. Okay, so let's see what happens here in our perfect storm. So, of course, they raised money. So, you know by now, they drink. Interestingly enough, nothing happens during the weekend. It's all good. Everything works. We have the support, the customer success team. They might have some work to do, but generally, everything works good until Monday. Now, on Monday, you remember Legal? So she went to her own conference. It turns out that they have their own conferences when they speak about fascinating things like LGPL 2.2 and this kind of stuff. So she comes back very, very excited. She goes to Billy and say, Billy, I heard that we are not allowed to use LGPL 2.1.2 anymore. Do we have any dependencies with this license? And Billy goes like, has no idea. Now, a couple of good things. First of all, Billy has now developers that can do the work for him. And also, all the dependencies are centralized in one place, their repository. So he sends his developers to go through all the dependencies in their repository and analyze the licenses. Maybe they're in POM XML, maybe they are in package.json, nuspec, license files, headers of sources, or my favorite, nowhere. Eventually they come with some list, and it might be that they do have this LGPL of the unapproved version, and what do they do now? They need to remediate, which is a nice word to say you are not allowed to use this dependency anymore, good luck, find an alternative, implementing everything around it, and the release is still tomorrow. Well, okay, this happens. And then another call for Billy, and this time it's from the CFO. And she asks Billy, Billy, what will be our operational costs for next year for our production servers in Amazon? Billy goes like, but then he actually remembers, 42. 42 will be the right number. Why? First of all, because he has no idea. Second, no one will cut operation servers if everything is good and he is over budget, right? So he's pretty safe. This guy, who knows this guy? Will It Blend? Okay, good. Will It Blend is a fascinating YouTube channel that all of you should start watching, in which those guys blend things. Stuff like iPads, brooms, cameras, bricks, and a lot of fun stuff, just, I guess, to prove that their blenders are good. In our example, it will be, will it scale? The head of the sales comes to Billy and asks, will it scale? We have a very high-profile customer, very high load. We expect very high load, and we need to know, will it scale? And Billy actually goes to the source of the scalability, who are the developers. And he's like, guys, so what do you say? Will it scale? And they're like, absolutely. Sure, of course. We wrote it. It's a great code. Everything is fine. It will scale. And how do they know? They have no idea, but, well, I promised you everybody die. This is where everybody dies. It didn't scale. Now, I come to you from California, and as you probably know, there is no such thing as bad ending in any Hollywood movie, so we will attach a happy epilogue to our Greek tragedy. And Smokey the Bear is the symbol of proactive firefighting in the United States, and this is why he was selected to represent a proactive improvement. The last stage of that team can be in order to not only firefight or prevent existing fires, but actually reactively improve and prevent even future fires to happen. It's all about process and tools. The people are plenty. And stuff like performance and scalability testing now. And there are tools to do that, actually can ensure the quality and the scalability of tools. License and security management can help you fight stuff like, do we have this license, or do we have now Strat2 dependency somewhere 4 layers deep in our Docker container, hidden and waiting to be exploited by some hackers. Proactive performance and trends review, they have NPM for a while now, but only this stage they actually start to do this weekly review of trends to actually see if there is a degradation somewhere that they can prevent before bad things happen. Non-functional definition of done is an interesting one because it actually means that aspects of ops, of performance, of scalability are now coded in what they are doing. And how those aspects can be coded, how can we guarantee that our new service in our microservices world will have monitoring endpoint, proper log configuration, etc., etc. How can we guarantee that? You know the answer. We are in Devops talk. Docker. Now, jokes aside, it's actually one of the things that are very easily and very well done in Docker. You can actually put all those infrastructures in your base images. And then where you inherit from those base images, you already have kind of a box with all the infrastructure ready for you. All the logs are already pre-configured. All the monitoring endpoints are already set up. It's very easy for you to write code, and it's very easy for the organizational infrastructure to plug into your new code. So this is one of the ways you can code this non-functional definition of done into your infrastructure. There are tools, as I mentioned, to tackle a lot, but it's mostly the process and the culture, but tools are important as well. So of new parts, stuff like JFrog Xray can help you monitor your licenses and security vulnerabilities and proactively react before it goes to production and bumps there. BlazeMeter or tons of other cloud performance testing tools that can generate tremendous load on your system without you required to set up all this infrastructure. Service virtualization, of which you can think as mocks for huge external objects like American Express transaction systems if they do not expose their own testing facilities. So there are tools that help, but the biggest problem is using those tools correctly and embracing them, which is, of course, about process and people. Now, we'll see just a couple of examples of how we can battle those problems with those tools. So you remember, this is Billy guessing what will be the operational expenses in the next year, and I will show you a quick example of a very sophisticated and expensive tool. Not a lot of you can get access, Microsoft Excel. My point is, it doesn't really matter what you use. It matters that you take a look at the numbers that are already in your hand. This is an engineering effort allocation for a sprint of a company. And the interesting part here, of course, is that the head of engineering might think that they work on a big feature A, but they actually spend only 6% of them. Most of the effort goes into something that is called keeping the lights on, which is fixing bugs, making maintenance, and making all different of technological depth fighting, etc., etc. Now, all you need to do is start writing it down in any tool, and then magical things happen. Suddenly, you have better visibility in what's going on. And the last example that I want to give you is about the quality of the tool, right? So you ask the developers and the quality is awesome, but actually, what is the one and only important metric of quality of your product?
Customer satisfaction.
Customer satisfaction. And how do you measure customer satisfaction?
Feedbacks.
Feedbacks in terms of how the customers say they are unhappy? Money, sales, but for the existing product, tickets, issues, defects, right? If something doesn't work, probably the tool is not good enough. And here's an example again that's from Leonid's old team. Bugs in a quarter organized by severity. 65% severity 1, severity 2. Is it a good product? Not so much. He can go and shout on his developers about the quality of their product. But now, let's take the same data and organize it differently, grouping them by resolution. Suddenly, more than half of those severity 1 and severity 2 are resolved by information provided from the R&D team to a support. The problem is not with the quality of the tool. The problem is with the training of the support team, right? And all we did is we looked at a little bit more information. Now I have 1 minute for an epi myth. Who knows what happy means? No one does. My wife knows. She's a major in theater. That's why she knows. It's a moral of the story. And the moral, there are a couple of points. First of all, scale is a scale. And scale is a scale means you cannot jump from one stage to another. You cannot start a startup and say, you know what, I will be proactive improvement, let's implement safe. That's a suicide, because that will be too much process. Teams evolve from one state to another naturally, and although you know the happy ending, you cannot fast forward to it until you go through all of them. And tools, process, and people, all of them have to change in order to achieve it. And I will leave you with three, I would say, main things about what we learned today. You build it, you own it is kind of the basic of DevOps. This is what DevOps is. Data is a key, and you saw a couple of examples for that. It's extremely important, especially when you progress through the scale. And of course, my favorite, pain is instructional. When you bring the pain to the people that are responsible for this pain trend to disappear. Other people say it nicely. What do they say? If you fail, do it more. Well, pain is instructional feels much better to me. With that, thank you very much. I'm at JBaruch on Twitter. This is Leonid Igolnik, who co-authored this talk with me. We are Devoxx 2017. JFrog.com/show-notes is the place to find the slides, the video, the raffle, and everything else. And you are more than invited to visit our next talk about a completely different subject, battle between Google Home and Amazon Alexa in their Java extensions, in half an hour in room 10. That was a very shameless plug. Thank you very much. Oh, don't forget to vote, because there are some people on top that we need to beat.